Hello, everybody. This is your Zoom meeting for June 24th at 9 o'clock in the morning. I want to start talking about Chapter 4, covalent compounds. And I'm going to cover about half of the chapter pretty quickly because it's not too difficult as a chapter. A little bit easier than ionic, probably. So a covalent compound, exactly what is it? It means that you are dealing with molecules. And a molecule is what we call the smallest particle of a covalent compound. Okay, kind of like H2O, water. The smallest particle would be that oxygen and the two hydrogens bonded together. There's the lone pairs. Okay, we'll be talking about the Lewis structure also in this chapter. So in the last chapter, we had ionic compounds. And ionic compounds, you have a metal bonded to a non-metal. And they weren't actually bonded. They just had electrostatic attraction. What the heck does that mean? That means that a positive charge is attracted to a negative charge, or a cation to an anion. And the smallest particle of an ionic substance is called a formula unit. Took me a minute there. It's not really called a molecule, okay? A formula unit, because ionic substances are attracted, all positive charges are attracted equally to negative charges around them. And likewise, negative charges are attracted to the positive charges around them, and so on throughout that entire unit that we call a crystal. Okay, and you know that salt is a crystal if you look at it close enough, NaCl, sodium chloride. Now, covalent compounds are bonded. They share electrons. They do not transfer. Ionic transfers electrons. Molecular shares electrons. That's the big difference. And so we're going to be looking at that with Lewis structures. So don't forget, an ionic substance is metal to non-metal. A covalent compound is a non-metal to a non-metal. Now, even though there are far fewer non-metals, many fewer, there's actually more covalent compounds, and that's mostly because there's just so many permutations of the sharing of electrons, many more possibilities. All right, so now you know it's a non-metal to a non-metal. Now, how do we know specifically how strong that bond is? We need to use something called electronegativity. And electronegativity is on page 125. There are the values. Do not memorize that, but you just need to know how to use that table. So if you have that table in front of you, and let's say that you have a compound like water, okay? So you would look up this bond right here, okay? Let me back up just a little bit. This atom right here, oxygen, has an electronegativity value of 3.5. Okay, there's no units on it. It's about the only thing in chemistry that doesn't have units. And hydrogen is 2 plus 2.1. Each hydrogen is 2.1. Now, what that's measuring is how much these electrons that are shared, who's going to have the electrons most of the time in that tug of war. Make sure you read about electronegativity. In this particular tug of war between oxygen and hydrogen, oxygen is going to have the electrons most of the time because it has a higher electronegativity. And so in this bond, we say that the hydrogen is slightly negative, and, excuse me, the oxygen is slightly negative, and the hydrogen is slightly positive. Likewise, this hydrogen over here. And we'll talk more about how that affects the polarity of the entire molecule later. So let's do another one. Let's just say that you've got some random molecule like lithium bonded to fluorine. Now, I already said that if you have a metal bonded to a nonmetal, which is exactly what you have here, then you would have an ionic substance. So let's talk about that. So lithium has an electronegativity of 1. Fluorine is 4. Their electronegativity difference is very, very high. So I'll give you another page number here. On page 126, it says in table 4.3 that if the electronegativity difference is more than 1.9, which this is, it has a difference of 3. Okay, we're not talking about a positive or negative difference. Just what is the overall difference? It's 3, not negative or positive, just 3. If it's greater than 2, then that is an ionic bond. Let's look at another one. Let's say that you have a bond between carbon and nitrogen. Carbon is 2.5. Nitrogen is 3 overall. They have a difference of 0.5. Remember, I don't want negatives there. It's just what is the overall difference. And it says in table 4.3, 0.5, well, that's kind of on the borderline, okay? It could be nonpolar, it could be polar covalent. But you have to have a little more information about the properties of this compound. So there really isn't an overall cutoff, but what we do know is it's definitely covalent. And it has a tendency to have a little bit of polarity, a little bit polar. And again, we would recognize that the nitrogen is slightly negative because it has a greater electronegativity, and the carbon would be slightly positive. Okay, we'll talk about that a lot more in my next lesson, where we look at the overall polarity of the molecule. I want to talk very quickly about naming. Very simple. You're going to name the first compound, for example, let's just take that carbon nitrogen compound, CN. Okay, you're going to name the first compound, carbon, and then you're going to name the second one, but you're going to change the ending to IDE. That's it. Now, in addition, you have to tell how many of the second molecule, second atom, okay? So you're going to have, you only have 1 carbon and you have 1 nitrogen. So we're going to use the prefix mono. That tells us we have 1. Let's do a, let's have a compound where we've got let's say we've got 3 carbons and 2 nitrogens. All right, so we have to tell how many. Tricarbon, there's 2 of them, dinitride. Remember, we want to change the second element to that IDE ending. If the first element has just one, like carbon dioxide, we can skip the first element if it's mono. Only if it's mono. Why? Because it's easier to say, and that is convention. That's just how they started naming them. So that's the way we're going to name them. I don't know who decided that. All right, our next lesson, I don't know if there's any questions out there. If there's anybody out there, let me know if you have questions. Ask them now. Our next lesson will be on drawing Lewis structures. You must know very well dot diagrams for the compounds. We did that in the last chapter. All right, that's it for today. Very short lesson. I didn't hear anybody speak up about questions. So if you have questions for the next Zoom lesson or a daily tip, send them on to me in an email.